Yo, what's up, guys? Welcome back. One second, let me send this text. I can close my door. Oh shit, I'm back. Okay. Anyway, yeah, sorry. Been a long day today. Worked on my C++ project. So that was fun. Got a little bit of functionality working. But yeah, thought I'd probably do a quick problem here. Just on stream. Probably do it in Python, C++. I guess we'll kind of see what the problem that we're gonna work on is. Then I think I'm gonna take some rest today. Just spend some time. Feel like I've been go, you know, so recently. So did we do this one yesterday? No. I've been so go, so I think I'm gonna take a little rest and kind of relax, maybe watch a movie and spend time doing my thing. So but yeah. Maybe I should. Oh no, I'm not gonna be here for the weekly contest. Shit, I was thinking about doing it, but I'm curious. Let's jump and take a look at some. Let's grab some problems to look at. I kind of want to take a look at this problem. I feel like I should look at bit manipulation problems. But yeah, let's take a look at 2411 1938. Taking a look at this problem. Given a zero X-ray nums at length n consisting of non-negative integers for each index of minimum size non-empty subarray of nums starting at I inclusive that has maximum possible bitwise OR. In other words, that would be the bitwise OR of the subarray. You need to find the smallest subarray starting at I. Okay. The bitwise OR of an array is a bitwise OR of all the numbers in it. Return an integer array answer of size n where answer I is the length of the minimum size array starting at I with maximum bitwise OR. So I can see why the thing said it was a sliding window, and also a binary search. Starting at any index is 3. So how are we starting at index 0? The shortest subarray that yields is 102. Zero, 2, 1, 2. Starting at x2, the shortest subarray is 2, 1. Starting at x3, the shortest subarray is 1, 3. Therefore, we return 3, 3, 2, 2, 1. Oh my gosh. Okay, I understand what we're doing here, right? So let's grab this here. Let's put this up here. So we're given these nums, right? We want to start here, right? So I'm gonna start with with white, right? Oh, whoops. Oh, Jesus. Okay, yeah. So we're going to start here, right? We're going to look for the subarray that has the maximum possible bitwise OR. You know, so that could either be 10, 102, 101, 10213, right? In this case here, starting at index 0, the shortest subarray yields 102, right? The shortest subarray. The maximum possible bitwise OR starting at any index is 3. Maximum possible bitwise OR starting at any index is 3. I'm gonna ask AI to help me understand the question better, just so I can fully comprehend what we're doing here, because I thought that's what we were doing, but what are we doing in this question? No code. Let's take a look. Given integer array nums for every index I, consider all the subarrays. Nums I, okay, yeah, it's all in nums n minus 1. Among these, find the subarray that has the maximum bitwise or possible among those starting at index I. Has the smallest way to achieve that OR. You need to return an array res, where res I is the length of the smallest subarray starting at index I that gives the maximum OR possible from that position. Okay. Index 0, the maximum OR we can get from 0 is 1, 0, 2, which is 3. The smallest subarray starting at 0 that gives OR 3 is 1, 0, 2, length 3. At index 1, the maximum OR from there is 0, 2, 1. Is equal to 3. At index 2, the max OR is 2. 1, which is 3. Smallest subarray 2 already gives 3. At index 2, we have 2, 1. 2, 1, then we have 1, 3, and then we obviously have 3. So 3, 3, 2, 2, 1. Trying to think, what is the best way to solve this problem? Guess we want to look at the constraints here, right? So, as equal to num's length, we got 1. That's the power of 5. Nums I can be anything above 0, so we don't have to deal with negative numbers. That's good. What? Okay. Started with bit manipulation, ended with bit humiliation. Doing leak code after a night shift feels really tired. To load segment trees. What the fuck is segment trees? Segment trees. I'm not familiar with a segment tree. It's data structure that stores information about an array. Yo, what's up, Ethan? Here we go, Ethan, dude. Another bit manipulation problem, dude. Your favorite, bruh. You're the bit manipulation king. So I don't really have an idea about how I would go about solving this, or at least I have the intuition. LMAO, yeah, bro. Yeah, you know, I'm not sure at this problem. I really struggle. I think I really got to start from the beginning in terms of bit manipulation problems. Maybe that's what I should do, actually. You know, instead of doing a problem like this, I think I got to build my intuition from the ground up and work on my bit manipulation. And I feel like this is probably a good time to bit manipulation, B code set. Holy fuck, dude. Look at all these problems, bro. I think I should work through this course, dude. Maybe. Oh my gosh, dude. I didn't want to fucking... divide two integers, add binary subsets. Oh, this is the one we did yesterday. Subsets. There we go. Subsets to single number, repeated DNA sequences, number of 1 bits. I think we should start off probably with the easy problems. I'm probably going to get cooked here on some of these bit manipulation problems because I do know that when I did them, I guess add binary. Let's just do add binary first. Why not? Given two binary strings, A and B, return their sum as a binary string. Well, we'll give it 1, 1, 1. Try some easy problems. Yeah, that's what I just did. Oh, yeah, you deleted the message. We were thinking the same thing, bro. I'm trying to think, like, how to add binary numbers. I have to relook at this, bro. It's been so long. It's been so long, dude.
And now you have 1 plus 1 plus 1. Well, that's going to be 3, but you can't write 3. Once again, 3 in decimal.
Because I did solve this problem, but I guarantee you I did it some, like, stupid way. Like, yeah, like... yeah, like... I don't think that's solving the problem properly. So, you know, at the time when I was doing this, I was probably just like, oh, like, you know, yeah, I solved it or whatever. But, you know, really, if we're looking for a proper answer, I don't think that counts as a proper answer, to be honest. Let's find a better video. I don't like that video. Adding in binary video. 2 minutes. Oh. Nice. Redirected me to Khan Academy, dude. Let's go.
Hi, this is John. I'm going to show you a really easy way to do binary addition. Now, before we start working out the problems, I want to show you some of the rules we're going to follow to make it really easy. The first thing I'm going to show you is the magic table of binary addition. 0 plus 0 equals 0. 0 plus 1 equals 1. 1 plus 0 equals 1. 1 plus 1 always equals 1, 0. Some of the other things we're going to follow is we're always going to add 2 digits at a time to keep it simple. We're always going to work in 1 column at a time. And we're going to do a quick check in decimal just to check our work. Now for our first example, I put the magic table off to the left just as a reference. So we have 110 plus 101. Well, let's just work it out. 0 plus 1, looking at the table, equals 1. 1 plus 0, looking at the table, equals 1. And 1 plus 1 equals 1, 0, looking at the table. Put our 0 down, carry the 1 to the next column. Now we have that carried 1, and we're just going to bring that down. So 110 plus 101 equals 1011 according to our table. Let's check it in decimal just to be sure. So we up at the top I put a decimal to binary conversion table. So and you just add up the ones in the columns. So here we have a 1 under the 4. 4 plus 2, we have a 1 under the 2 equals 6. 5 and want to be correct. Let's 0 1 plus 1 1 1 0 1. So starting from the right, working left. 1 plus 1 equals 1, 0, correct? So we put our 0 down, carry our 1. Now here we have two numbers. So 1 plus 0, right? We have our carried 1 plus 0. That equals 1. Now that 1 plus the 0 that it's over equals 1. See how we're doing it here? 1. So we put our 0 down, carry our 1. Now here we have two numbers. So 1 plus 0, right? We have our carried 1 plus 0. That equals 1. Now that 1 plus the 0 that it's over equals 1. See how we're doing it here? 1 plus 1, well, in the next column we have 1 plus 1, that equals 1, 0. Put our 0 down, carry our 1. 1 plus 0 equals 1. 1 plus 1 is 0, 1. 1 plus 1 is 0, 1. So here we put our 0
Bro,
down
it's been forever
and carry
since
our
I've
1
done
to
this,
the next
like-
column. 0 plus 1
Oh.
equals 1. And we have a single carried 1 left over. We can just bring that down. So our final answer is 110010. Let's check our work. So in this column we have, in our very top row we have 16 plus 4 plus 1, that equals 21. Below that is 16 plus 8 plus 4 plus 1 equals 29. In our answer we have 32 plus 16 plus 2, and that's 50. Well, 21 plus 29 definitely equals 50, so we know that to be correct. Well, thanks for watching.
Okay. Let's get rid of this, right? So we're given the number in binary, right? So I guess that works out, right? So what if we're given, I have to learn this, dude. 1 1 shit 1 1 B, what is B1? So what would this just be? 1 2 4. Okay, so we're doing what, 3? 3 plus 1 is 4. Okay. I guess we can do 0 1. So when we go about this, 1 plus 1 is, well, 1, but like we carry the 1 here, dude, right? 1 plus 1 is equal to 10. Oh no. Okay, 1 plus 1 is 10. 1 plus 1 is 10. Carry the 1. 1 plus 0. Which is 3. Which is 3 in decimal, which is 1 in decimal. 1 plus 1 is equal to 10. Write 0, carry 1. 1 plus 0 plus carry 1 is equal to 10. So we got 1 plus 1, which is 10, plus 0 is what? 10 again. Carry the 1. 1 0 0. Okay. Let's try a different one. I need to get this, bro. I need to understand this, or else I'm not going to be able to do it properly if I don't get it on a fundamental level. So what we have, okay, 1 0 1 0. Do you make games also? Do I make games? I'm working on a game. I know I don't make games like for a living or anything, and I'm not any good at it, so yes and no, I guess. Okay. So we have 0, 1. So 0, 1 is 1, right? Every single time. We see that, or 1, 0, right? Then we have 1, 1, which is 1, 1 is 10. So we have a 0, we carry the 1. 0, 0 is 1, plus 1 is 1 here. Then we have 1, 1, which is 10, 0, carry the 1. So what is this? This is 2, so this is 10. This number here is 10. What is this? 1, 2, 3, 4, 8, 8. This is 11. So what do we have here? We go 1, 2, 4, 5, 8, 16, 16, 8, 20, 21. Oh, we added it right. There we go. Wow. Professional. Let's do another one. This is fun, bro. Let's do another one. Can I type in this, dude? The fuck? Let's do 1, 1, 0, 1, 1, 0, 1. Let's do a big one, dude. We gotta get crazy here. And let's do like, let's do something weird like 1, 1, 1, 0. Bro is the bit manipulator now. There you go, dude. I am the bit manipulator, dude. Okay. Let's take a look at this. Ah, man, dude. I gotta make this smaller, dude. So we have 1, 1. Let's put this up. 1, 1, 0, 1, 0, 1, 1. Then we have what? 0, 1, 1, 1, 0, 0, 0. Okay, 1, 0. We have what? 1. Then we have 1, 1, which is 10. 0, carry the 1. 1, 0, 1. So that is technically 1, 1. So then we get 10 again. Carry the 1. 1, 1, 1. I don't think we've had that come up. 1, 1, 1. What will we do when we get 1, 1, 1? What do we do when we get 1, 1, 1? When adding binary and you count 3 ones from A, carry 1, you're asking what is the result of 1 plus 1 plus 1? Write 1 to the result, carry 1 to the next higher bit. 1, 1, 1. Here. Carry the 1. 0, 0, 1. 1, 0, 1. So I guess this is what we got here. Now we have to figure out what this is. This is 1, 2, 3, 4, 8, 16, 32. So 32, 16, 8, 40, 42, 43. So this is 43. What is this here? This is 2, 4, 6, 8, 14. 47. So we want, this is hopefully 57. Is it 57? I don't know. 32, 0, sorry, 1, 2, 4, 8, 16, 16, 8, 24. This is 32. 30. Yeah, this is 57. Shit, dude, I did it. Goated. Learned it, dude. There you go, bro. Takes 5 minutes. Yeah, just to make sure, this is 32, 16, 8, 1. So 32 plus 16 is what? 38, 48. Plus this is 56. This side is 56 plus the 1. Right, plus the 1 is then 57, right? Which is what we get. Okay, so now we can do it. So now we can kind of think about a little bit more about the logic, right? Now, how the fuck would you do this? Good job. Let's go, Ethan. Let's go. Thanks for the getting me inspired to do some bit manipulation, bro. Shit, dude. Trying to think. So I guess we're given the bits here, right? We want to start from here, right? Because we are doing this. This is our first bit here, right? This would be our greatest bit, right? So I believe for starters, what we'd want to do here is maybe so I is the length of A minus 1. J is equal to the length of B minus 1. So actually in the last value here in our string, right? I guess what we would want to go, probably have a while loop, right? While I is greater than 0 and J is greater than 0. Oh wait, we'll have different distances. So like for example on this string here, we'd need to deal with that probably in the code. I'm trying to think. It's greater than 0. We want it to be greater than or equal to 0, right? Probably want to have our carry here, right? Have a carry value. I'm trying to think. Okay. So while I is greater than or equal to 0, we man, it feels weird to struggle on some of these like easy level problems, dude. I guess I mean that's what you get when you don't really learn the section properly, so while I is greater than or equal to 0 and J is greater than or equal to 0, what do we want to do? Well, we want to look at both our values, right? We want to look at what are we looking at here, right? So how we want to do this in code, I'm trying to think. 1 plus 0 is 1, so we put a 1. What are we returning? We're returning our new string, so maybe we probably need a string as well, right? So call it like res string is equal to this. Do we want to do a bunch of if statements in here? I just don't know if that's the way to think about it. I just don't know. Trying to think. Okay, well. I do know that we're going to have to convert to an integer, right? So, bit A is equal to integer nums I is equal to integer, casting it into an integer first, right? Because we're working with a string. So will we need a bounds check here though? Right, because nums j might not exist, right? So I'm feeling like now that's why I feel like if we need multiple conditions, right? If I feel like this would be an or here, not an and this would be a carry here, right? Or carry being if this carry is 1, right? Because if these are out of bounds but our carry is also 1, then we also want to add our final value over here, right? Because we could have 0, 0 here. So we convert. Maybe we need a bounds check here. So like if j is less than 0, then bit b is equal to 0. I guess if I is less than 0, bit a is equal to 0. I guess we can do like maybe an else here. If it's not, then we do our shit, right? This is probably a stupid way to think about it, but I don't know, but bit a, get rid of it. Alright. Let's move this. Okay. So do our checks here. Do our balance check. So now we have the value. So now we're at least looking at a proper value, right? So now how can we simulate our bit manipulation here? Maybe like our total is equal to bit A plus bit B plus carry. How would we want to work with that? I'm trying to think. If we get our total, really, like, what can we get here? We can get a 1, we can get 0, we can get 2, or we can get 3. I mean 1, 2, 3 or 0, the values we can get here. I feel like, bro, there's so much of a better way to do this, but will we check each thing? Like if we get a 0 or we get a 1 or we get a 2 or we get a 3, like I'm trying to think here, right? So if this is out of bounds here, then obviously we would have a 0, right? Because if we would have something and our j is out of bounds, then this will automatically be a 0 here. So I think that's correct in terms of the way I'm thinking about it. If it's equal to 0, then we keep nums j what we're at. We have our carry, right? So maybe the only way to think about it would be to do the separate if statements, right? So maybe maybe we can do a switch here too. Let me same thing, right? Like, switch statement, Python. Um, um, sorry guys. I'm trying to think here. Okay, sorry, I had to talk to a friend. Would a switch be the best to do here? I don't know. Okay. So maybe we can do, okay, well, if, so really how would we do this, right? We'd have separate if statements, right? So if our total is this, we do this, right? Else if our total is this, we do this. The total is this, right? We would do this, right? So if our total is 0, what do we do when our total is 0? Well, we make res string plus or equal to total. I guess we would have to probably convert this to a string as well, I think. I'm not sure, but anyway, I guess we'll see when we run it. So if it's 1, right, that means we had a 1, 0, so we can probably just add it as well, right? Plus or equal to string total. If we have a 2, what do we want to do? Well, we do res string. I guess we need to do our carry as well, right? So our carry would be 0. Our carry would be 0. We have a res string here, we get a 2, right? A 2 means that we got 1, 1. When we get 1, 1, we add a 0 and carry the 1. So res plus or equal to string 0. And then our carry is 1 here. Then our res string plus or equal to, if we have a 3, we have 3 1s. We res a 1, right? And then we would keep our carry at 1, right? Yeah, I think that looks good. I'm trying to think of in the case here, if we had only a carry, it would come down here and it would still work, because we would do 0 plus 0 plus 1, right? And then our carry would be 1. So I think that should return fine. Return res string. Let's see how this goes. Nums is not defined. What the fuck is this called? String. Jeez, dude, I'm so used to it being called nums, bro. String is not subscriptable. It's not called string. Oh my gosh, dude, it's called A. Bruh. Okay. Oh, we're not incrementing. That's why we're getting infinite while. We're not incrementing here, so what? It would be I minus or equal to 1, j minus or equal to 1. Okay, and I think now all we have to do here is we have to do reversed res string. I think that should pass. Dude, oh my gosh. Maybe just like res string dot reverse. I have to look into how. Bro. I have to look up how to reverse it, dude. How would we do it? Oh yeah, like this. That's right. Okay. So we have our res string. We slice, but we go the other way. There we go. Okay. Sweet. Hopefully this submits. Let's go, dude. Let's go. We learned some bit manipulation today. Let's go. So instead of doing this problem November 20th, what is that? 8 months ago, 9 months ago, and doing it some bullshit way, using base 2, we successfully did some bit manipulation. So that's a dub. That is a dub. That is a W in my eyes, dude. W. Let's take a look at Nicode's bit manipulation. So what did we just do? We did add binary. He doesn't have that in here. So how about we take a look at single number and actually do it properly instead of doing it the bullshit way. I think it is very beneficial just to learn this. You know, a non-empty array of integers nums, every element appears twice except for one. Find that single one. Given a non-empty array of nums, every element appears twice except for one. Okay. Every element appears twice except for one. So we're given this. Okay. I guarantee you, if anyone is watching this, I guarantee you the way I solve this is probably with a hash set. Some bullshit way. Like, I solved this June 8th, probably some bullshit way. Okay. From memory, I think this means Zor. In Python. I think. God, Google can't even answer my question. What does this mean? Yeah, it is a Zor operator. Okay. So, maybe here... Okay, yeah. Back in November, I solved it using a dictionary. But I'm sure you could just do this using a set as well, right? Oh, no, one element. I mean, you could. Could solve it using a set. But anyway, point is that we're going to solve it using bit manipulation. I did sadly look at the answer, but, you know, that's my bad. But I guess we can kind of look at it more on like a fundamental level on why that worked. Because I honestly don't remember why I did that. It was a little while ago. It was in June, so about 2 months ago. So what does a Zor exactly do? So here we're looking for a single number, and the single number that doesn't appear, right? So I guess fundamentally we can look at what does Zoring do, because I don't remember off the top of my head. I am a very forgetful person. I'm sure people have realized that. So, and you know what? I'm gonna do this one in C++, because I feel like that's also important as well. So let's pull this up. Single number 136. Oh man, E++. Okay. Looks like we're good. We want to fetch. What do we want to fetch? 136. Fetch 136. Single number. Okay. Well, obviously we're given a numbers array, right? And I guess we can look at how we were given it, right? So just an array of integers, right? What do we do when we XOR an element, right? So if we're given a number 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 0. Exclusive OR, so is that what XOR means? Exclusive OR, right? XOR is exclusive OR. Yeah, okay, you said that, Ethan. XOR is exclusive OR, only values if true if one input is true. Let's take a look here. So, okay, right. So with an OR would be, yeah. So an OR would be, okay, if both are true, 1, 1, right? 1, 1 OR would come out as true, right? But with a XOR, only one of them has to be true. So, okay. That is something that I need to remember, dude. I'm gonna write that down. Like what you told me, Ethan. I gotta write down my shit to remember my stuff. I'm gonna make a bit manipulation page here, just for me to go through this, because I want to learn this properly. So we have bit manipulation. All right. I'm gonna draw my table here. Right. So what do we have here? A, B, Y. And for people that might be thinking, oh man, didn't you learn this in college? Yeah, I did learn it in college, but you know, it's been a little while, man. Sometimes you forget. I do have a very forgetful memory, so you know, if I'm not doing something all the time, sometimes it goes out the window, man. But obviously you get that knowledge still, you know. You never forget how to do things, it's just you get rusty, so. 1, 1. Okay. 1, 1, 1. So for you guys, just I'm writing down the exclusive OR here, just so I can kind of get this into my head. A, B, Y, B, Y. It's kind of fun doing the easy problems, dude. Like, I don't have to think like so crazily about everything. 0, 1, 1, 1, 0, 1, 1, 1, 1. I remember this shit like driving me crazy, dude, in my like computer architecture class back in the day. Back in the day, man. Back when times were simpler, dude. Okay. So let's take a look here, right? Let's kind of pull this up here. So we're given 2, 1. 2, 2, 1, right? I assume you can do this in one for loop, right? I mean, we did look at it, right? So I'm trying to think how we did it, right? Well, we kept some sort of like, I don't know, variable. I guess we can call it current, right? Being 0, right? We had a for loop here, right? We looped through each value, right? So I guess we did. I guess we could start it being 0 because if we see something, we're automatically going to get a 1, right? So we loop, we compare 0, so 0 here, 1, right? Would be our first for, right? Because we're comparing our cur, right? Our cur being here. And then 1 being like the value that we're looking at, right? I guess we should probably change this. Actually, it's probably a little bit confusing to look at, right? So we can be like prefix or something. Because we're doing it kind of in a prefix way, right? And this being our cur, I guess we can rename this to prefix. Right? Our cur being the value that we're looking at right here. Oh, whoops. Be this one here, right? Oh, I guess it could be whatever, right? I mean, we can look at 2 as well, right? So 2 would be... how do we get a fucking eraser, dude? Eraser. Here we go. Nice. Okay. We are given 0, 1, right? Right, so this would be 0 here. So I believe if we XOR this, this will come out as 1. Right? I believe. Right? Because if we had 0, 0 would be 0. 0, 1 would be 1. Will that come out as 2? Let me think about it. So first of all, I guess we can do have our int cur is equal to 0, right? Being our prefix, actually we can call this our prefix. Alright, we can have for I is equal to 0. I guess we can do I nums, right? For I nums, right? How do we XOR in C++? C++ bit manipulation. Where is the documentation? Okay. Shift operators, bitwise. So it is the same, it looks like. Bitwise XOR compares each of its bits' first operand with the corresponding bit of its second operand. So if we go back to what we were looking at here, we see 0. So 0, 1, 0 will give us 1, 0, right? I think will give us 2 again, right? But if we were to compare, okay, 2 and 2, and we would XOR that, what are we trying to return again? We're trying to return the element that's not there. So 2 and 2 would give us what? 1 0 1 0, and we would resolve this. 0 0 would be 0, right? 0 0 would be 0. This would come out as 0. I need the trick to click in my head, bro. Zeroing a number from itself results in a 0. I'm trying to get the underlying functionality, right? Like, I know what to do here, right? I feel like, I don't know if you can do this in C++. Sorry, I guess prefix equal to I. Is this a thing in C++, dude? Right, I think, but I want to understand the underlying, like, functionality of why. Okay, we got build errors. Okay, so, oh. Why do you prefer using Visual Studio? Because I can use the compiler. Or if you're talking about specifically for C++, my buddy just got me on it, and to be honest, I'd rather use a compiler than anything else. So, it's more simple. Visual Studio. So Visual Studio has a debugger. There you go. 36. What do you use INV run? Yeah, what is my error here, dude? I don't even know what this is, bro. I don't know what this means. Binary operator not be found. Takes a right-hand operand of const. I don't know what this means, dude. There's no acceptable conversion. Am I not like Genie? I'm not familiar with that, bro, to be honest. That's cool, dude. Do I have to specifically import something here? Is that why I'm not sure what my error is. Scroll down to the test cases. Oh my gosh, dude, I'm putting this inside of Python, dude. What am I doing? Whoops, dude. Okay. I think it's trying to print a whole vector. That's my fault. Ah, nah, dude, you're good, bro. I need to understand the underlying functionality here. Why this is doing this. I need to get my fucking microphone out of my face, dude. Right, because I'm trying to fully understand oh, fuck. Okay, I understand. I understand what we're doing here. How long till you graduate, man? I've already graduated, bro. Okay, I understand what it's doing here. We're just adding up the Zords, right? So, okay. I didn't realize that, but... So, we're given 0, right? So, we have our 0, right? So, then we Zor 0 with 2, right? And when we Zor 0 with 2, we get 0, 0, 1, 0. So, we would get 1 here, right? I think. Okay. Then we Zor, whoops. We Zor 1 with 2, right? So we would get, what, 0, 1, 1, 0. I think 0, 1 being 1, this one being, wait, hang on. 0, 0, 0, 1, we would get 2, sorry. I think this would be 2. Do you work or is this your full time? Yeah, I was interning, dude. So I guess the follow-up question here was, did you complete any internships? Yeah, I did 3. I did 3 internships. I work on, you know, projects and stuff. I do lead code. Done a little bit of system design. I don't really know. I wouldn't really consider myself a that I know system design at all. I definitely have to probably study a little bit. Yeah, 0 Zor 2 is 2. Yeah, I fixed it. But yeah, I did internships. I did, you know, mostly what everyone does. So just yeah. So 0 Zor by any number is just the number itself. Yeah. Okay. So we do 0 Zor 2. Yeah. So when you do 0 Zor by any number. Yeah. I'm going over bit manipulation, dude. I kind of skipped over it, dude. I kind of did, like, you know, I didn't really learn bit manipulation. 2 Zor 2 is equal to 0. Yeah. Yeah. Sorry, I'm just talking to you guys, so sorry. So just the last one that doesn't have a pair. Well, you're already ahead, man. Keep grinding. Thank you, bro. Appreciate it, dude. Yeah, I realized that, Super Gem. Thank you. How many leak code problems you got? I've solved nearly. Good luck. Well, doing better than people who don't. Yeah, dude, I've solved like nearly 500. 467 problems. The reason why I'm going over easy problems of bit manipulation is just because I kind of skipped over it. I didn't really look at it because I just hated bit manipulation problems. I just kind of didn't really want to do them. So I'm really just trying to get my fundamentals here and just really understand. You know, because I was looking at bit manipulation problems yesterday with my buddy here on stream, and I was struggling a lot. So I'm just trying to get those fundamentals again. God damn, bro. Yeah, dude, I've done a lot. I've done a shit ton of problems, dude. Oh, fuck. I've done, yeah, 1,300 submissions this past year, and I pretty much did it every day, nearly. I mean, I missed out here and there. All these days, bro, in here is literally me just going, is me going to visit my girlfriend, dude. Those are the days that I just went to visit my girlfriend, dude, literally, and every other day I've never missed a problem when I've been at home. So I've always made videos. I mean, you can see, like, if you look, nah, bro, that's addiction. Yeah, dude, I just love doing them, to be honest, dude. Like, you should try to solve the subsets problem again using bit masks. I will. I'm gonna get there. I want to get the fundamentals first, Ethan. Like, I want to do the easy problems, get the fundamentals, and, like, build my way up. But, yes, I will. Yeah, I guess. I don't know. I just enjoy doing the problems, dude, to be honest. I enjoy learning. I enjoy computer science. I enjoy, you know, working on my projects and stuff. So it's fun, bro. But yeah, that's my life. So yeah, all these days me visiting my girlfriend. So my leak code submission is 0. One leak code problem a day keeps unemployment away. Yeah, it does, dude. It does. I don't know. I started this channel to just keep me consistent. To be honest, I just fell in love with doing it. I just fell in love with doing the problems and learning and, like, sharing it with other people. I was a little scared at first, like, people fucking, you know, chirping me on the internet, like, you know, calling me stupid or whatever. And I feel like that's probably what everyone, like, is scared to deal with when kind of putting themselves out there a little bit. But I don't know. I just decided, like, I was like, fuck it, dude. I just, you know, wanted to put myself out there. When I grow up, I want to be like you. Dude, I appreciate it, bro. Thank you. I'm nothing special, but appreciate that. How many interviews so far, though? I've just only started applying, bro. So, honestly, none yet. So, none coming up. So, I'm looking for a job for January right now. So, I just finished interning somewhere, and I'm going to continue to put out my applications and stuff for something for January, so for the new year. So I'm probably gonna start applying here in August. But yeah, it's still kind of early, but yeah, so I'm gonna be doing these videos for a little while still, but so would appreciate you there coming along. Okay, so anyway, let's finish this problem here. So we were looking here, we did, oh sorry, 0, 1, so 0 XOR 2, which is 2, right? And then we do, we have, so 2 here, 2, so we would do, hang on, we would have 1, 0, 1, 0. So XORing itself here, we'd get 0, right? Then we'd come here and we do what? 0 XOR 1. So 0, 0, 0, 1. We would just get 1, 0. So that's why we get 1, and we would just return our result, right? Okay, I understand. So I guess every time you were XORing with stuff, it cancels each other out. Give him some time. We need to do at least 1,000 applications first of all. Yep, that is true. Probably. Not looking forward to it, but probably. Bro, who cares about others' opinions? It's your decision. You make your career, not them. So keep grinding. Appreciate it, bro. Thank you for that. That's very, very kind of you. Thank you. Anyway, so we got there. Let's do one more problem. So we've done this successfully. Single number of 1 bits. Let's take a look at this one. Oh my gosh, dude. 1 bits leak code. Okay, given a positive integer n, write a function that returns the number of set bits in its binary representation known as the Hamming weight. Bro, I have no idea what the fuck this is. Of a string is the number of symbols that are different from 0 in the alphabet used. Okay, so we're counting the amount of 1s. Interesting. Okay. So, well, given n here, we got 1, 1. Our output is 3. The input binary string 1, 0, 1, 1 has a total of 3 set bits. Okay, so we're looking at 11 here. So 1, 2, 4, 8. Yeah, okay, so that's 11. Again, you know, I solved this problem. I bet you I probably just fucking converted it to a fucking integer or converted it to binary and then just counted the 1s with a for loop or something. I don't know if that's probably the way that you want to do it here, but or in terms of there's like a bit manipulation way to do this, I wouldn't know. Divide and conquer. Yeah, I guarantee you when I did this, I just converted it to base 2 or something. Yeah, there you go. And just, yeah, looped through and counted the 1. Interesting. Anyway, so I really don't know the proper way to do this problem. I generally wouldn't really know kind of where to start, to be completely honest. So I'm going to look it up on the internet. How to count number of 1 bits using bit manipulation. Counting number of 1 bits also known as having weight. I guess we can put this on the screen here. The Brian Kerrigan's algorithm, whatever the hell this is. Initialize a count variable to 0. The variable will store the number of set bits. Enter a while loop that is not equal to 0. Start the loop. Increment by 1. Return the count. Okay, increment count by 1. Update n by performing the bitwise AND operation. N is equal to n and n minus 1. This operation effectively removes the rightmost 1 bit from n. Okay, this is something a little bit more advanced for my small-brained bit manipulation knowledge. Let's take a look at something. Where is my stuff here? Okay. Let's think about this. I gotta write this down, dude. I'm gonna put this on the screen over here. Gotta think about this, right? So we're given n is equal to 11, right? So let's put this on our screen. We're given n is equal to 11, right? How do we want to do this? We want a count, right? So talk about a count being 0. Okay. We want this variable will store the number of set bits. Enter a while loop that continues as long as n is not equal to 0. So, okay, we'll have some sort of while, right? While n is greater than 0, right? And then inside the loop here, we want to update n by performing the bitwise AND operation. So, n, the current number that we're looking at, 11, bitwise AND. Holy shit, dude. You were teaching me how to do this, Ethan. Can I fucking clutch up and do the bitwise AND? Is that right? No. Fuck, I was kind of close. Hang on, dude. This is where I need to lock in, dude. Fuck, dude. Okay, I'm gonna leave it like that. Bitwise AND, right? N minus 1, right? So technically we're doing 11. Fuck, dude, how I can't do it. Bitwise AND. Need to lock in, dude. Can I do this? There we go. Bitwise AND. You got it. There you go, bro. Type shit, dude. 11. And so what are we doing here, right? When we have an AND here, I guess we can do a little AND table. All right, we have AB 0 0 1 0 0 1 1 1. Also be right back. Sounds good, bro. Then AND here. This is false. This is false. This is false. This is true. Bitwise AND. Okay. So we are doing 1 1 1 0, the bitwise AND of this, right? So what does this give us? This gives us 0 1. Oh wait, shit, no, we're not doing that in binary. That's integer value, shit. So 11 would be 1 1 0 1, and 10 would be 1 0 1 0. We take the bitwise AND of this. So what does this give us, right? We would go 1 0, which would be 0 1 0 1. Is that the bitwise AND? No, right? Yeah. What does that give us? What, 10? What is it meant to do? Hang on, I lost the thing I was looking at, dude. What the fuck? How to find number of 1 bits in an integer. I guess we have to find the number of 1 bits of the Hemingway. Look at the last bit. If it's 1, increment a counter. Shift the number to the right by 1 to examine the next bit and repeat until the number becomes 0. Subtracting 1 from a number flips the rightmost 1 bit to 0. Oh, okay, so we're flipping the rightmost bit here to 0. Doing n and n minus 1 removes the lowest set bit. Count how many times you can do this before the number becomes 0. That's the number of 1s. Okay. Great. Right, so if we were to do, okay. So what do? We had a count here, right? Count being 0. When count is 0. We have while n, so while n is greater than 0, we loop, right? And we would do n is equal to n and actually I have to check the difference in C++. I forget this, dude. Ethan's told me so many times, but I keep forgetting difference between and C++. Single ampersand, bitwise AND operator when used integral types like int, char, and bitwise AND. Okay, double ampersand logic AND operator. Used to combine 2 Boolean expressions. It values to true only if both of it's true. Okay. So bitwise AND is AND, the double ampersand is the logic operator. Okay. Right. Shubham Ham Prasad says great. Thank you, bro. Appreciate it, dude. Okay. N and n minus 1. Right? When we do that, what do? Well, n and n minus 1 is equal to 10. So then what, we would increase count by 1, right? I believe what we're just returning count. Oh, we're missing a semicolon. I'm gonna create a little missing more fucking colons then. Jeez, man. There we go. Okay. Need to write this down, dude, because I have peanut brain, dude. Think about what I learned today, right? So we learned about, we're going through this, we learned about single number, right? Which was finding the unique number, right? And what do we do here? We use a ZOL, right? We use a ZOL prefix sum. And then what we looked at, number of 1 bits. So we learned that ANDing with n and n minus 1 removes lowest bit, right? And then we had a count, right? Counting. Yo, what's up, bro? Matthew Sahagun, what's up, man? Nice to meet you, bro. And we also learned about adding bits, right? A little refresher on that. This is 10, this is 11. Sorry guys, you guys can't see this on my notepad, dude. I'm writing this shit down, dude. My bad. Okay, sweet. Let's take a look at counting bits. We can just kind of race through these easy problems. I feel like these are pretty straightforward. Again, I feel like I've probably looked at these, but not actually done the bit manipulation way in order to solve it. I mean, I have solved it. I guess we can kind of laugh at how I solved it before. Yeah, I mean, I just looped through with a for loop, but okay, whatever. Let's take a look here. So given an integer n, return an array n's of length n plus 1, such that for each I, 0 is less than or equal to I is less than or equal to n, n's I is a number of 1s in a binary representation of I. So we're given 5. Okay, we're doing an array here. So this is what 0 would be, this is what 1 would be, this is what 2 would be, 3, 4, 5. Okay, so let's think about kind of what we did and how we can kind of apply what we've learnt to this problem. So let me write these down. Oh wait. So 338, counting bits. How can we count the amount of 1s at each section? Let's grab a new area here. So we're given input n is equal to 2, right? Guess we're going to leave our output here as well. Hi there, first time here. Why leak code? Why not projects? I work on projects, bro. I just do leak code on streams, dude. That's all it is. Like, I do everything. So appreciate the comment though, but I work on projects pretty much all day, and I just stream at night myself doing leak code or working on leak code problems. So yeah, bro. Okay. Give an integer and return an array and something like that plus 1. So I is the number of ones in the binary representation of I. So if we, so I'm thinking maybe, how can we use bit manipulation here? I'm thinking obviously we're gonna have some sort of while loop here, right? Right. Going through each value, so maybe we can start, like, we can have our you know, whatever that is, like, you know, count variable, right, starting at 0, right? So we can go through each value. So while count, you know, is less than or equal to n, right? Then we can do whatever down here, right? But how can we figure out how many ones are in here using bit manipulation? We learned that to count the number of 1 bits in something. Let's go back to the previous problem. Oh my gosh, dude. Gotta refresh this, dude. No, did I not submit the other one? Whoops. I don't think I submitted it. Okay. How were we doing this here? We were... It'd be the same. I mean, maybe a similar thing. Removes the lowest bit count. I mean, maybe we can apply the same sort of thing. At a total of 3 set bits. I mean, we are doing the same thing. Can we just do the same thing here, really? Like, I don't know. Maybe it's very easy to come up with an O of n log n. Can you do an O of n possibly in a single pass? Any built-in functions, built-in pop count, C++. I mean, if I did it the same way as before, good luck. Okay, good luck, bro. Thank you, M&W. Appreciate the kind words, bro. Thank you. Okay, so let's just try it out. Let's do in count is equal to 0. Right, we can have our count while count is less than or equal to n, right? We can do what we did earlier, right? So we had Count is equal to maybe I feel like this is probably where we have to look at the shift operators. I have a feeling like, so let's look at the C++ documentation on that. C++. Abbreviation C++. Oh my gosh, dude, why is it so hard to find the documentation, bro? Like, dude, this is ridiculous. Shift all the bits to the left, operand to the left by the number of possibilities of right operand, right shift. Back. Yo, what's up, Ethan? We're on a different problem right now, and I'm looking at the C++ documentation. Filled with 0, shift all the bits to the left, operand to the left by the number of positions specified by the right operand. I feel like we can, there is some way that we can, some one-liner here that involves some sort of like operation here, but dude, I'm not sure. I'm not sure. Let's look at some of the hits usually. Think of OVN solutions. Maybe we should probably stop thinking about the OVN solution and just write the problem. I'll take a look at a solution because I'm not sure. Sol n+1. What the fuck does this do, dude? So this is the OVN solution. I don't know what this does in C++. Like, this here. Is this specifying the size of the vector? Right. I think it is, right? Declares variable name sol, which is vector, can hold it just n+1. Initial size of the vector, meaning it will create n+1 in elements. Okay, that's what I thought. Okay. Okay. Yeah, I'm a little lost here. A little helper function here. The helper function, what does it do? Count plus equal to n%2. Oh my gosh, dude. Wow. Yeah, I would not have thought about that. So it looks like here they just divide by 2 and then just count. Ah, man, that's such a smart way to go about it, bro. I would have never thought about that, dude. Fuck. Well, that's frustrating. I was kind of thinking about it the same way that we did the last problem, but it's so different. Damn. Okay. Well, looks like here. So, what do they do here, right? We have our count bits function. So I guess we can leave this count here, right? Looks like here what they do is they have the vector here. They pass in n+1, right? And then they loop through. I is less than, I believe, result size I++, right? Actually, no, I think this is n, actually. It could be the same thing, actually, but I guess it's the same thing, but whatever, we'll just change the n, just for practical sake. And we have a helper function here, so they call the helper function, right? So I guess we can call it count ones, right? And I guess they pass in the what we're looking at, right? So I believe this would be less than or equal to n, not less than n, because we want everything, right? Out here we have a helper function here, right? So in count ones we have our num, right? Inside of our count ones function, so while it's cheating, but I think you can use SED pop count in set bits, SED pop count n, just so you know. Pop count n, what does that do? I guess that's probably, yeah, that's probably cheating, right? I mean, yeah. Trying to think about it the real way, but thank you. Yeah, I do appreciate that. I did something similar in Python when I solved this. I want to think about the real way to solve this because I really want to have that good, you know, foundation of these problems. Shit. Yes, actually we want I is equal to this. Get rid of this count here. Come down here. Get rid of this. So while num, that means while it's not 0, right? Yes, we can initialize our count here instead. While num, looks like here they go count is equal to what, num %2, modulus 2. Modulus 2, and then what they do, x divide by 2. Sorry, num divide by 2. So, taking the modulus, so use a count. So modulus 2 gives the least significant bit LSB of num in binary 1, 0, right? So we take the remainder, that's why. I can understand that. If the last bit is 1, increment the count. Divide the number by 2, right shift by 1. This removes the last bit, so then you can check the next one. Count is equal to 1. Second iteration. And then outside of here, we just return our count, right? And then here we would just return our res. I think. Forgetting a colon. Always forget these fucking colons, dude, when I'm going in between Python and C++, bro. So frustrating. Oh. How much time are you learning coding, and how old are you? I just turned 24, probably about 2 weeks ago. And how much time did I spend learning coding? I don't know. I've been programming for a few years. Probably 3 or 4 years, but I really started taking it seriously probably about a year ago. I'm not specialized in anything, so I kind of just, I've done a bit of everything. So, yeah, kind of wish I was a little bit more specialized, but I mean, by this point, I've kind of dipped my hand in a little bit of everything, but, not an expert or anything. Not an expert in anything whatsoever. I mean, I feel like that's pretty tough, but, yeah, so that's a little bit about me, bro. What are we getting here? Use of undeclared identifier, did you mean return? Okay, so I think we can submit it now. There we go. Okay. I'm going to write this down. Got to get that memory flowing, dude. So, what do we do here? I guess we can give a little bit of a summary. We use the helper function. Now you're choosing in-depth learning. Now you're choosing in-depth learning. I don't know what you mean by that. I'm just doing leak code problems, dude. So, specifically bit manipulation right now because I struggle with it a lot. So, if you could expand on what you're trying to say, I could probably answer it better. Sorry, I'm not sure what you mean. I mean, deep learning of things. Yeah, I mean, yeah, just kind of doing these to, I work on projects. I work on, leak code problems to help with my problem solving ability, kind of like my understanding of, I guess, algorithms in a way, and data structures, and, computer science fundamentals and stuff like that. To one, get ready for interviews, and just to get better overall. So, yeah, just do a bit of everything. But yeah, I'm gonna call the stream there. Appreciate you guys watching. Happy just doing a few problems of bit manipulation just to kind of get my intuition up there. But I mean, you can only get better. Just gotta keep showing up every day and keep doing them, and it eventually comes. But appreciate you guys watching. I'm gonna end the stream there. I have my Discord in the description. Would love to see you guys join. I think we got about 30 people in the Discord now. We're getting, I think 35 actually, probably getting close to 40. So if that interests you, more than welcome to join. So just trying to create a little community of, you know, like-minded people, and yeah, so appreciate you guys watching.